to be talking about how oxygen binds to heme. So first we need to talk about some just overall definitions and kind of get a picture of what each of these kind of proteins look like. So in the top right corner you can see this is what a myoglobin protein looks like, which has simple oxygen binding behavior. In the middle here you can see some red dots and some black lines, which is kind of zoomed in on this. This is what your hemoglobin is. This is a protein that delivers oxygen to tissue throughout the body. It's a tetramer of myoglobin, like polypeptides. You can see it's kind of just situated in between these 8 alpha helices. So the heme is just kind of tightly wedged in this little hydrophobic pocket between 2 of the helixes. Here's kind of just a breakdown of that hemoglobin molecule. You can see that you have iron situated right here in the middle of the protein, and that is what is responsible for binding to oxygen up here. So as oxygen comes into contact, O2, when it comes into contact with heme, is able to bind to the iron, which is stabilized by the amino acids around it, allowing it to enter through the iron and then also release as well from the iron, as it is just stabilized in this myoglobin. So, moving on. So it's also important to understand the relationship between oxygen and myoglobin. As your oxygen increases, so as the PO2 increases, just the overall oxygen in the body, the more oxygen binds to myoglobin. So as you can see, as oxygen goes up, your myoglobin increases and becomes saturated. Here you can see the Bauer effect. This is, so basically oxygen is going to be there's going to be more oxygen in the lungs than there are the capillaries. This is because this is where you are inhaling those outside O2 molecules. And then by the time, and this is where most of your O2 is going to bind with the myoglobin. As it enters the bloodstream into the capillaries, most of your O2 is already on a myoglobin, so your PO2 is going to be slightly decreased in the capillaries as it starts to transport through the body and deliver hemoglobin to muscle tissue, which is the point of hemoglobin, is to deliver oxygen throughout the body. So as that process happens, just oxygen in the capillaries is going to decrease. In this model diagram here, what it shows is how the oxygen that you inhale, as you can see I'm kind of moving my cursor around right here, you inhale it into lungs, and then as it gets into the blood, it's going to start combining with this hemoglobin. And what happens is that you can see it is transported to the muscles, where it then takes on a CO2. And what happens here is that now that you have CO2 coming back through the bloodstream as it makes its way back to the lung to be exhaled. So what happens is that a carbonic acid is formed at this point, which is going to, right here, dissociate into hydrogen and bicarbonate ions, which is going to decrease the pH in the capillaries. The pH in the capillaries decreases. This is because you have an increase in CO2, which in turn is going to make the blood more acidic. So once the CO2, you have that acidic blood building up, and once you get back to the lungs, this is when you're able to blow off your excess CO2 and inhale more O2 to keep a more neutral overall body pH.